So the other essential piece is this idea of a positive feedback, and to know whether or not our warming is mostly caused directly from CO2 emissions or from greenhouse gas emissions, or whether or not it actually is mostly coming from these feedbacks. So the idea is that like we're putting CO2 into the atmosphere, we're putting greenhouse gases into the atmosphere, that's changing the Earth's energy budget. But that's not the end of the story, because that's changing temperature. And can you think about like what else in this diagram might change if global temperatures are changing? So there's definitely, I mean, there's all sorts of things that happen when it gets warmer, but this idea of a feedback is something that's going to be affecting the energy budget and thus affecting temperature again. So if you can't envision that, then it's not going to be a feedback. So feedbacks are something that we're all kind of familiar with in daily life, and we see them all over the place. So colloquially, they get called like a feedback loop or snowball effect. So, you know, small snowball rolls and gets bigger and bigger and bigger. Chain reaction, vicious cycle. These are usually words for positive feedbacks. The technical definition of a feedback is, this usually comes from like engineering textbooks, is when the outputs of a system are routed back as inputs as part of a chain of cause and effect that forms a circuit or a loop. So a circuit just means a loop. So it just means that like something is, that the output of something gets routed back in as the input, and then can, you know, go in this cycle and cause the initial change to either be much larger than it would be otherwise, and those are the ones we tend to focus on, or it can inhibit the initial change. So it can feedback and kind of shut down whatever the initial change was. And so I think the classic example that like everyone is most familiar with is just the audio microphone feedback, where you have a microphone next to the speaker that it's hooked up to, and you tap the microphone, and so then that is amplified by the amplifier, comes out the speaker, goes back into the microphone. This feedback loop exists, and you get this large shriek. So you can kind of just touch something, get it going, and it goes by itself. So that's the idea there. So when we talk about feedbacks in the Earth system, they have to be something that, you know, the temperature is changing, that's causing a change, and then this is somehow going to affect temperature again. It can't just end with temperature changes, and so then that causes this, you know, negative impact or something. So the one that people got that is very important is what's called the Ice-albedo feedback. All that is that these, as it gets warmer, as we put more greenhouse gases in the atmosphere and it gets warmer, our ice decreases, our ice melts. So both our ice on our on land, so alpine glaciers, and to some extent our ice sheets, although they're so big that they're not really exposing Earth underneath them yet. But our sea ice for sure. So sea ice in the Arctic is, you know, very reflective, and it's on top of an ocean, which is very dark. And so as that melts, you are changing a surface that is very reflective to a surface that is very dark, and is going to be absorbing more of this radiation, this shortwave radiation coming from the sun, and causing further warming. So that's one, the Ice-albedo feedback. Another important one is the water vapor feedback. So these molecules that I've been showing here, this is CO2, this one is methane, and the other one is water. So water in the form of gas, call that water vapor. As the Earth gets warmer, as the atmosphere gets warmer, the atmosphere, one way of putting it is the atmosphere can hold more water vapor. And so when it gets warmer, more of this water that used to be liquid in the ocean ends up going into the atmosphere. And so that means more greenhouse gases in the atmosphere. And so that means more inhibition of outgoing long-wave radiation. Makes it even harder for the outgoing long-wave radiation to get out, and so causes a further increase in temperature. So there's the Ice-albedo feedback, water vapor feedback are both very important positive feedbacks. They're causing more warming than there would be otherwise. And again, they have to do this through one of these mechanisms. And there's not going to be a feedback that's going to change the amount of energy coming from the sun. So it's really, of those three fundamental ways to change the Earth's energy budget, there's only two that feedbacks can work through. They can only change the greenhouse effect or the amount of radiation reflected to space, the albedo. They're not going to feed back and change the amount coming from the sun. So the cloud feedback is a hugely important feedback, and it is largely unknown, actually, after decades and decades of research. And so we don't even know the sign of the cloud feedback, whether or not it's a positive feedback or a negative feedback. So whether or not it causes the Earth to get more warm than it would be otherwise, or less warm than it would be otherwise. And you can kind of tell just from this diagram why the clouds might be very complicated. And that's because they're over here interacting with shortwave radiation, and they're over here interacting with longwave radiation. And so exactly how they change and how they change seasonally, and whether or not it's more during the day or at night, and what altitude and all that affects what the actual sign of the cloud feedback is. And so I'll just mention it here, that this is like one of the main uncertainties in climate science. It's one of the main reasons that there is kind of a large error bar in terms of how much warming we're expecting over the next century and over the next several centuries. That if the cloud feedback is positive, then we expect much more warming. And if the cloud feedback is negative, then we expect less warming, but still warming. And so this is kind of important, that this does not mean that we don't know the effect of clouds on the Earth's temperature. So the feedback is different. The feedback is, when it warms, how are clouds going to change? And is that change going to cause more warming or less warming? We know that clouds cause the Earth to be cooler than it would be otherwise. So if you were to delete all the clouds instantaneously from the Earth would warm up a lot. So that's a distinction there, that like the feedback is, how do clouds change with warming? Clouds themselves, we know, have a cooling effect on the Earth. And so that should be intuitive as well. The cloudy days tend to be colder. So there's other feedbacks we worry about. We worry about carbon feedbacks. So that carbon feedbacks are feedbacks that basically, as it gets warmer, more greenhouse gases in the form of methane and CO2 end up in the atmosphere. So one of those ways is through thawing permafrost, that we have all of this carbon frozen in cold places. And as it gets warmer, bacteria start to eat that carbon, or eat that organic material, and metabolize it and release CO2 and methane into the atmosphere. And so then that's, it's not the direct release of carbon from fossil fuel burning, it's carbon that's coming from soil and from the ground that was released because it got warmer. So that's what makes it a feedback, is that it's the temperature causing something that's going to affect temperature again. And then one other one I'll mention is a carbon feedback from the ocean, that CO2, we have CO2 in the ocean, and it turns out that warmer waters make it harder for CO2 to dissolve in that water. So this is like the soda can, that when your soda is warm and you open it, you get a much bigger like pop, and that's the CO2 escaping. And that happens, that effect is much larger when the soda is warm compared to when it's cold, because cold liquids are better able to have CO2 dissolved in them. So the point is, when you warm up the ocean, it ends up releasing CO2 to the atmosphere. So these are all positive feedbacks. It turns out that these positive feedbacks are responsible for the majority of warming that we've seen historically, and that we expect to see going forward. So we have direct warming that comes about through increasing greenhouse gas concentrations from fossil fuel burning. And then we have this indirect warming that comes from these feedbacks, from the ice melting, from water vapor increasing in the atmosphere, from more carbon going into the atmosphere from these carbon feedbacks. And those are responsible for actually like 2/3 of the warming that we've seen and that we continue to expect to see. So that is this last class learning outcome. Describe what a positive feedback is, and know whether most of the human-caused warming comes directly from our emissions of CO2 or from positive feedbacks. So it mostly comes from positive feedbacks.